Hi, everyone. Today, we're going to be talking about exploratory data analysis, and we'll do this in parts. And first, we're going to focus on categorical data. And we're going to talk about contingency tables and proportions, bar plots, no pie charts, and Simpson's paradox. Some of this content comes from our textbook, Montana State Introductory Statistics, and the first set of lectures are focused on categorical data. So here's a sample of some categorical data. We have, looks like 6 rows, and it's from a data set that you may have access to. And we see 1, 2, 3, 4, 5 variables. And this is, let me ask you a question, Paul. Which variable is a categorical variable and which is a quantitative variable? Pause the video and think about it. Well, it's clear that type is a categorical variable, format is a categorical variable, and number is a categorical variable. Even though number sounds like a numeric variable, so you always got to be careful with that. And number of characters looks numeric, and line breaks looks numeric. So this is a data of emails. So these are characteristics of emails. And each record is an email or an instance of an email. And if we look at the description of the data looks like a table, right? But let's not confuse the description of the data table with the actual table of the data set or the data frame. And here is always good or necessary to have the information about what the variables are. What does type mean? Type could be anything, type of email, type, what kind of type, whether the email was a spam or not. That's what this type is. And here's more description of the variable. So always important to understand what the variables are and the possible set of values for each variable. Frequency tables and proportions, a very simple and very useful construction is what we call the frequency table. And it's just the frequency of a particular variable. And here we're focused on the number variable, so-called number variable. And we see that for non-number, so this is the variable category. We're talking about categorical variable, but this is statistics. So numbers are always going to come in here. So there's the frequency of these categories. None, there's 549, small, there's 2,827, and big, so-called big number, that is, there's the presence of a big number, is 545. And remember, the number is the categorical variable saying whether there was no number, a small number, under 1 million, or a big number in the email. And it's also important to have the relative frequency, because these numbers kind of are difficult to compare or really use if we don't have a relative measurement. And so here is a relative frequency table. And what happened is we just divide each of the categories, the frequency of each categories, by the total of the 3 categories combined. So this 392.1 is 549 plus 2827 plus 545. And then here we write the percentage. And in this table, you could just have the percentage written either in this format, 14%, or in a more calculable number. So this is the same as 14%, 0.14. This is 0.72, and this is 0.14, and this should sum to 100%. Of course, these numbers are rounded. That's the relative frequency table. Now, what we often use are the two-way tables, also called contingency tables, and these are tables for 2 variables, 2 categorical variables, and the values in the tables are the frequencies of the categorical variables. And often what we do is we're looking for associations. So in this case, we want to see whether or not, for example, the number variable, number characteristic of emails has any impact on the type. That is, whether the email is a spam or it's not a spam. So we put it in this way. And at this point, do you see any association between the number variable and the type variable? Does it seem like if some numbers are present, it leads to more spam or not? You can pause the video and think about it. Let's discuss it. Well, one way to look at it is to look at this total here, the total of spam and the total of not spam. So for spam, there's 3554. For not spam, there's 367. But this tells us that there is much more spam email than not spam in this data set. So we had the total. What was the total? 3921. So we had 3554 over 3921. And this is the proportion of emails that are spam. Maybe I'll call this the unconditional proportion. And that's just the proportion of spams over not spam in this particular data set, regardless of number present. Now, what we may be interested in is the conditional proportion. That is, the proportion of spam and not spam within a particular category, in this case, the category of number. So how do we determine that? Well, we identify the proportion of spam and not spam within each category. So for example, for the first one, I have written down here just the percentages. We have 400 divided by 549. So that's going to be 73% for none. Let's say none. For small, we have 2659 divided by 2827, which is 94%. And then for big, we have 495 divided by 545, which is about 91%. So what is this? So within the emails that have no numbers, 73% of them were spam, and then you can just easily deduce 27% were not spam, right? It's just the difference from 100. Within the small, 90%, with a small number, 90% of them were spam, and only 6 were not spam. And then with the big numbers, 91% of them were spam and 9% were not spam. So what do you think? Is there an association between number and type? Well, from this very exploratory investigation, there seems to be an association between number and type, because this seems like a substantial difference. Now, whether or not this is a substantial or what we call significant difference requires some other testing, which we'll learn later. But for now, it does seem like there is an association, because there is a substantial or notable difference in the percentages of spams within emails that have different types of numbers. Also, let's note that there are different calculations. Namely, there is the column calculations that we did here. So within non-emails, how much were spam, how much were not. Within small emails, how much were spam, how much were not. And of course, we can also do the row calculations. And these are different numbers. They're not necessarily the same. And they also look into the association between these two variables, but they are different and they may require investigation as well. So within spam messages, and here's we already calculated from the proportions. So within spam, 11% were had no numbers, 75% had small numbers, and 13% had big numbers. So we can also see a differentiation here. Just within spam, we see that there seems to be an impact or an association between the number categories and the spam categories. And then not spam, it's interesting. Within the not spam, we don't see a big difference between none and small, but we definitely see a big difference with big numbers. So this is part of the explorations we need to do to examine if there is an association between variables, and we do that via contingency tables and proportions. Just some note on notation. Let's recall that we're often working with samples when we're working with statistics, and sometimes with the whole population of the data. And proportions calculated from a sample of data instead of just P, it's usually denoted by P hat. So every time we see like a P hat, the hat is a reference to a sample. So P hat means the sample proportion, whereas then the P would be the population proportion. Just a note on nomenclature here that is important to remember. Next, we'll talk about bar plots and Simpson's paradox.